Okay, in this video, I will introduce the periodic table of the elements um, and start going over characteristics of our modern periodic table. So, our modern periodic table is attributed to a Russian chemist named Dmitry Mendeleev, who was the first to order elements based on their atomic mass. When he did that, he also saw a repeating pattern of properties. So put all the elements in one row and saw that eventually you should start another row where the pattern of properties that went from left to right across the table would repeat. And he used the patterns to predict properties of elements that hadn't even been discovered yet when there were holes in his table. So that's really fascinating. And I think why it gets so much credit for this. So on our periodic table, we have metals on the left and non-metals on the right-hand side of the table. So over here in light blue are our metals, and then over here in dark blue on the right are our non-metals. So it's helpful to label that on one of your tables. 75% of the elements are actually metals. There's a whole lot of metals. They're usually solids at room temperature. So they're shiny solids. Some of those solids are pretty soft, but in general, they're shiny solids at room temperature. One key exception is actually mercury. So they're solids except for, here's a little photo of what some liquid mercury looks like. Again, so most of the metals, solids at room temperature. Mercury right here is an exception. It's actually a liquid at room temperature. They conduct heat and electricity quite well. Our nonmetals, we said, are on the upper right-hand side of the periodic table, except hydrogen. Hydrogen's kind of out of place in terms of properties. Hydrogen should go, over here on the right with our other nonmetals, right? Hydrogen is a nonmetal. And nonmetals can be found in all three states. Most of them are gases, but we also have liquid and solid nonmetals. And then, things like iodine, for example, is a solid. And so metalloids are part of this diagonal line of elements on the periodic table above and below the sort of darker line. And metalloids here are found in purple. And metalloids are really interesting in that they have some characteristics of metals, some of nonmetals, some of their characteristics are in between. For example, they can be semiconductors. So they can conduct a little bit. Silicon is a classic example of a semiconductor. And when we hear about the semiconductor industry and we hear about Silicon Valley, this is where computer processing chips are oftentimes, either researched or made, or we're talking about the use of silicon in computer processing. And so silicon's really interesting as a metalloid in that it is shiny and it does conduct electricity, but it doesn't conduct heat very well. And it's really brittle and can break easily. So this is really interesting because a lot of the nonmetals are more brittle. A lot of metals are, like pictured on the upper left, more smooth and could be cut with a knife, even though they're solids at room temperature. They're not, they tend to be bendable and what we call malleable, not brittle. Okay, so silicon's brittle, sort of like a nonmetal. It conducts electricity, sort of like a metal. It does not conduct heat. That's sort of like a nonmetal. And so it's kind of shiny like a metal. And so it's got this mix of metal, non properties. And so it's a true metalloid, one of these elements that's sort of in between. So if we look, we were talking about silicon, it's right here. And if we look at the table, again, hydrogen is really an exception in that it's a non-metal over here in a metals world. Here are all of our metals. And then here are our non-metals on the right-hand side of the table. And let's see. How about I move myself off the table a little bit there? It's a little ridiculous. If we look closer at silicon, and then at tin right here, and pretend that we're in Mendeleev's time and there was a gap in between those elements in that column that contains carbon and silicon. Let's pretend there's a gap and then there's tin. So Mendeleev predicted the properties of an element yet to be discovered, and he called it ecosilicon, really for after silicon. And again, here's kind of our staircase. Let's use another color. Our staircase separates the metals from the nonmetals with those metalloids. So how do we find it? I usually look for the line between boron and aluminum. That's where I start looking for my metalloids. And then I draw this line down and I start my stair steps there. And I draw them between each element just like this to about here. Now, when we get to here, these elements are man-made. You know, they have really short half-lives. They're radioactive. They're going to be breaking down. And so we just don't need to concern ourselves most with, you won't find, you know, concrete data about whether or not they'd be a metalloid or not. So we'll just focus on these elements. Aluminum we know has straight metallic properties, right? Aluminum is a metal all day long. We have aluminum cans in our everyday life. Hey, frankly, I've got a little Dr. Pepper one right here. So we've got solid metal cans in our everyday life, so we're pretty familiar with the fact that aluminum likes to have metallic properties. It's shiny, it'll conduct electricity. So what are our metalloids? They sit on or below a stair step like this. Boron, silicon, ecosilicon, arsenic, antimony, tellurium, polonium, for example. And that's a little messy. So if we want to clear that up, again, where were our metalloids? Boron, we made a stair step between boron and aluminum, and then we just kind of kept stepping down, and we went boron, silicon, ecosilicon, arsenic, antimony, tellurium, polonium, for example. Those are usually some of our classic metalloids. And it's the same ones that we've got in purple. I was just double checking on our slides as well. Okay, so what's this ecosilicon? Let's look at that a little bit more. So here's what Mendeleev did. He said, I've got silicon's properties, I've got tin's properties, and he predicted values right in between them. He predicted ecosilicon and its atomic mass and its predicted color and density. You know, he said if silicon resists acid and reacts with base, and tin reacts with acid and resists base, he predicted ecosilicon would resist both. He predicted that it would form compounds with 2 oxygen atoms, and lo and behold, germanium was quite a bit like he predicted. You know, close atomic mass, similar in color, similar in density, was resistant to both acid and base and did form compounds with 2 oxygen atoms. So I feel like, you know, that's why he gets a lot of credit. There were other people trying to order elements and coming up with pretty similar ideas about ordering them, but Mendeleev took it one step further with these predictions that were really wildly accurate, especially for his time frame, it feels like. So for our periodic table of the elements, what do we need to know? Okay, so it uses an accepted set of 1 and 2 letter abbreviations for elements. So some elements like hydrogen have just H for abbreviation. Then helium has HE. So we do uppercase H and a lowercase e. And we really work on making sure that the first letter is uppercase and the second letter is lowercase. Why might that matter? Let's use something like cobalt to show you why that matters. Capital C, little o means cobalt. Okay, but a big C and a little o, we're going to learn, means carbon monoxide, because that means that you have 1 carbon and you have 1 oxygen. And so it's going to be really important that we use that capital letter and that lowercase letter. And there are flashcards that we can use and cut out and practice those. So let's, you know, I really suggest that you do that. Okay. So I'm going to go ahead and get everything erased here. Oh, we talked a lot about the term metalloid, those elements that sit above or below a stair step, except aluminum, which is a really obvious metal. And those metalloids could also be called semi-metals. Some people call them semi-metals. So let's practice. Let's find some elements on the periodic table and classify them as metals, nonmetals, or metalloids. Okay, so let's find xenon, Xe. That's got atomic number 54. So it's definitely over here in this last column with the nonmetals. Now, it might be worth it right here, just non-metal, I should say. It might be worth it right here to redraw our staircase. Remember, it goes between boron and aluminum, and then down, and we just kind of keep going, usually ending about right there. And so remember, on the left, we've got all of our metals. On the right, we've got our non-metals. Hydrogen, in terms of properties, goes over here with the non-metals. And the metalloids are boron, not aluminum. We know that's a metal. Silicon, germanium, arsenic, antimony, tellurium, and polonium for the most part. Okay, so we've got tungsten, W, that's atomic number 74. And so that is most definitely a metal. And then we've got bromine, Br. Bromine's here, atomic number 35. And so bromine is a non-metal. We need to find arsenic, As. That's atomic number 33. Now that sits right on a staircase. So remember, the elements right on or right below, right on or right below, those are our metalloids, except aluminum, of course. So arsenic is technically a metalloid or a semi-metal. It's got properties in between metals and nonmetals. And then we're looking for cerium, Ce. So it's kind of tricky. It hangs out down here in what we call inner transition metals. These metals right here, we're going to learn, would actually go right here on the table. They go right in this area right here. If the table was sort of split open and was really long, it wouldn't fit very nicely on a piece of paper, but they would go right here. And so cerium down there is also a metal. So those are metals as well. Because again, they fit in this spot right here. That's where these two rows would go. And that doesn't look the nicest, so I'm going to erase that one more time and just let you know that those inner transition metals would go right here. Cerium's row goes right here, and then thorium's goes right here. And that's where those elements would belong. It's just our table would be super long and narrow, and it wouldn't fit very well on a piece of paper. So that's really the only reason that we do this. So again, we call these, actually, it's on this slide, lanthanides and actinides. And so here's where the lanthanides would go, and here's where the actinides would go. And these are also referred to as inner transition metals. Why transition metals? Well, over on the left, we for sure have metals, and on the right, we have nonmetals. And so in the middle, we're transitioning from metal over to nonmetals. Okay, so on our periodic table, there are these important groups or families. Group and family means the same thing. These are elements with similar chemical and physical properties, and they're often in the same column. Columns go up and down, they hold buildings up. This is a vertical column, can, hold up a building. And so our columns are called groups or families. So that first column on the periodic table is called the alkali metals. And then we have the alkaline earth metals. And then we start transitioning from metal to nonmetal. And so we have inner transition metals that go right here, the lanthanides and the actinides. And then we have just our transition metals. And then we don't have really names for, some of these groups here. Some of these groups are a little mixed up between they have like half nonmetals in them and half metals. And again, when we were talking about properties, metalloids were found here and here and here and here and here and here and here. Aluminum we know is a metal, so that's not a metalloid. And then we have the halogens and the noble gases. And people use these terms a lot. Alkali metal, alkaline earth, halogen, and noble gas are family names that do actually get used a lot on the periodic table. So those are really useful ones to know. Lots of times people label these columns. The alkali metals are the 1A. The alkaline earth metals are the 2A. Then we have 3A in that column where we've got aluminum. And then 4A for the column that's got carbon in it. And then 5A, 6A, 7A for the halogens, and 8A for the noble gases. So those are what we call our main group numbers and letters. That 1 through 8 are what we label as our main groups. So we like to label those main group or families with those designators 1 through 8 and say that we have those 8 main groups or columns on the periodic table. Okay, so what next? Well, hydrogen is really kind of different, right? I mentioned that hydrogen, is kind of an oddball here. It's a non-metal over in metal land, right? In a metals world. So this non-metal is colorless, it's diatomic, it comes as H2. It has a really low melting point and density, and we know it's really explosive, right? It's really flammable. Everything else in this column is called the alkali metals. Okay, so we've got hydrogen here, and then we've got alkali metals coming next. Those are low melting point metals. They have relatively low densities. These are very reactive. They're never found uncombined in their elemental state out there in nature, right? If we want some sodium, it's really lab produced because they're not found that way in nature. So these alkali metals are things like lithium, sodium, potassium, rubidium, and cesium. They are highly reactive with water, and so it's kind of fun to look at some of these alkali metal videos, and I'll post at least one of those for you because I think watching these alkali metals react with water is really pretty sweet. Okay, so up next, the alkaline earth metals. So alkaline earth metals are harder, they have higher melting points, and they are denser than the alkali metals. They're reactive, but they're not quite as reactive as the corresponding alkali metals. Okay, so alkaline earth metals are the 2A, and those are this second column here. We're talking about beryllium, magnesium, calcium, strontium, barium. Again, they'll react. We're seeing some nice bubbles, but we're not going to see these like fiery blasts that we do with the alkali metals. Magnesium, if you burn magnesium, it burns really bright white, like you can't stare into it. It's kind of fun to do if you're in person in the laboratories burning that magnesium. But it burns so bright and hot and white that you have to look away, right? And make sure you don't cause damage to your eyes. So pretty fun to do if you can, if you're in person, to do some chemistry at some point. Here we go. Halogens are over here in the 7A. These halogens are things like we've got chlorine. Chlorine gas is green. We've got iodine. Iodine's a solid at room temperature. And bromine is actually a liquid. So this particular column or family on the periodic table is really interesting because we go gas at fluorine, gas at chlorine, liquid at bromine, solid at iodine. We've got a liquid here with bromine, a solid with iodine, like these kind of dark purpley iodine crystals. They're kind of fun. These halogens are all diatomic, F2, Cl2, Br2, I2. They're really reactive elements. And then in that last column, in the 8A, we've got our noble gases. And they get that name noble gases from being like the nobility. They're very unreactive. So this idea that nobility didn't interact with common people, these elements don't commonly interact with other elements. You won't find helium just out there forming compounds with common old sodium. The way sodium chloride gets to, the way chlorine will get together with sodium to make sodium chloride, you'll never find helium or neon or argon doing that. So they're very unreactive. Not to say that they don't ever form any compounds. Never say never as a chemist. There's, compounds like xenon heptafluoride, where xenon does form some compounds with fluorine atoms, but their compounds are very rare. And so this last noble gases don't like to form very many compounds. But things like helium gas is used to blow up helium balloons. And in our neon signs, the element neon is actually red. So if you see neon signs that have other colors, that's actually from other gases that give off different characteristic colors, but the element neon itself will always be red. And so that concludes sort of our basics on the periodic table. Okay, but one last thing before we move on from the periodic table is just a little bit of practice. So this is a great time to hit pause and try these practice problems on your own. Okay, did you try these? Let's identify the following elements as metal, nonmetal, or metalloid. A transition element. Okay, so transition elements were here between what I sometimes jokingly call these goalposts. They are called transition metals for a reason. These are metals. An element in group 1A. 1A was right here. It was an alkali metal. If it's in 1A, it's an alkali metal. Elements in group 8A, that was over here. That was those noble gases. Those are nonmetals. The lightest element in the halogen family. Okay, so halogens were right here. They were in 7A. The lightest would be fluorine, and it would definitely be a non-metal. I notice we don't seem to have any metalloids here, but again, a reminder, those would be elements like boron, silicon, germanium, arsenic, antimony, tellurium, polonium. So we're looking at this stair step right here, everything except aluminum, because we know that it's a metal. Okay, so hopefully with this practice, you're feeling really confident about the periodic table.